Hello, everyone. Today I'm going to talk about Chapter 4 in Introduction Statistic Class. In this Chapter 4, I'm going to cover regression analysis, exploring association between variable. Okay, so let's start with section 4.1, visualizing variability with a scatter plot. So the scatter plot is like an order pairs x and y in mathematics, and we're gonna have like a point that's coordinate at x comma y. So we're going to use technology to create a scatter plot, and we're going to use scatter plot to investigate association between numerical variables. So let's go to slide number 3. Okay, so in the scatter plot, the primary tool for examining relationship between two numerical variables, which is x and y. So each point in the scatter plot represent one observation. Okay, so we're going to use some technology such as computer software program like StatCrunch, Excel, something like that. But mostly we work with StatCrunch in this class. Or you can also use a graphing calculator. So in order to do that, you may have to use TI-83 or TI-84 to do that. Okay, so let's move. So in this page, we have a graph, like a a scatter plot graph present for the median age of marriage for women. Actually, it should also be for women and for men. So I said man. All right. So each point in here, say this point, right? In scatter plot represent one state in the United States and the District of Columbia. Okay. So it's each point represent the median age of marriage for women and men in the state. So look like since it represent the median age for each state in US, so it should be about like 50 sample in here. So you should see about like 50 point in here, and and it's will represent the median age of marriage for women and men in the state. So for example, in this state, I think it's going to be around for men, I think it's about 24 years and 3 months. So I say or 4 months. So I'm gonna say 24.3 and comma for the median age of man, it's gonna be 27 point 27.2 years old. So something like that. And each data point has in the form at median age of woman. So this is for woman, right? Woman, and this is for man. Okay. So we move to the next one. So examining scatter plots gonna be have three features. One is the chain, which is it's like a center, or it's gonna be going up, or or going down, right? And the string is how spread of the data, and the shape. Is that a line, or is that a parabola, or maybe an exponent graph or something like that? So usually in here, in this class, we're going to talk about linear, which is a line, and non-linear. And we actually going to focus on linear. All right. So let's move to the next. Okay, the chain. The general tendency of the scatter plots, and you read from left to the right, typical chain. Okay, so it looks like increasing uphill. So if you have the data is like this, right? It's increasing, right? And so we call like positive association, right? And it increasing from the left to right. So in an opposite way, if you have the data is going down like this or down here, then we call negative association. And there's a case that it's neither up or down, and it's just everywhere. So we call no change. Okay, or neither an uphill or downhill tendency. Okay. Okay, so example for positive change. So as I say, if you see the point is going up, so then even though it's spread out like this, but is look like is mainly going up this way, right? So we're gonna say this positive change, and it's and because the graph goes uphill, as you can scan from left to right, this means as the age of the car increase. So in here is age of the car, right? Increasing, as it's increasing, then the miles driven is also going up. Okay, so let's move. All right, so this is another example for a negative change. This scatter plot show the negative change because the graph going downhill, right? See that downhill. As you can you scan from the left to right. This means as literacy rate increase. Okay, so this literacy rate increase, right? It increase from left to the right, right? The total birth per woman tend to decrease. So it decrease in total birth for women. So, okay, so for this scatter plot is show no change. It's spread. I mean, it's have everywhere, right? And it's follow no predictable pattern. You cannot have any prediction. Is that gonna going up or is it going down? It's just spread everywhere. Just up, down, up, down, up, down, up, down, something like that. You cannot know what happened in the future in here. So it looks like so this graph talk about the age and time for which means what for every age group, we can find relatively fast and relatively slow runner. Okay. Marathon running speed does not seem to be related to age of runner. Okay. So it looks like it doesn't have any relationship between age and time hours here, right? So let's move to the next page. Okay, so here is the one that have neither positive or negative. So you can see that at first it's going down, but then it's going up after zero, after x equals 0. So it's exactly like a parabola in this case. And this data set shows an association between two variables. There is a relationship between two variables, but we cannot be this one cannot be characterized as a positive or negative trend, you know. So okay, now let's talk about the strength of an association. Okay, so the scatter plot with a large amount of scatter, or vertical variation indicate a weak association. Okay, so so you can see in here the first graph here compared to the second graph. You see that the data is kind of for the first one is kind of like spread out a little bit, even though it is finally going up or positive trend, similar with the second one. But the second one have like a the way the association is kind of like very close to each other. So so we say the second one is stronger than the first one. Stronger association between height and weight for the second is stronger than the first one, right? Okay, so come back with this page. The scatter plots will, with a small amount of scatter or little vertical variation, indicate a strong association. Okay, so that is the thing that I just explained to you in this page. So the second one is stronger, and this one is weaker. Okay. All right, and there seems to be a stronger association between weight, size, and weight. Okay, so right, the height and the weight is weaker than the waist, and okay. So now let's move to the shape. So we mainly gonna talk about a linear in this class. For the non-linear, you may learn about that in the future in the higher level of the statistic. So scatter plot that's clustered around a line. So this is a line, or we call like a model linear chain. So model linear chain. And this scatter plot show there is a linear association between volume of searches for the word vampire and the word zombie. Okay. So you can see that the other point in here is trying to like a positive chain, and what else? Positive chain, and kind of like in here it's got like a strong one because it's close to each other, and also for the shape in here is clearly is a line because it's very straight. It's the model one is straight. It is like a most straight line. Okay. Now for the nonlinear, such a, in this problem you can see sometimes the chain in the data that are nonlinear chain. Even though in here is like a positive, you see that, right? It's keeping up a positive chain, but the model in here is like a curve, right? Yeah, or maybe in mathematics it's maybe an exponent, right? It up, but it up faster and faster at the end. It's not a line anymore. So this is an example of the nonlinear chain between temperature and the pollutant ozone levels. So the more temperature, the higher temperature, the higher pollutant ozone level, and it's even become faster pollutant for the ozone level. Okay. Writing description of association. Okay, so when we're writing a description of an association between two number variables, is always include chain, shape, and strength. So chain is as positive or negative, is that linear or non-linear. Okay, linear or non-linear. Strength is weak or strong. In addition, okay, mention in any observation that don't fit the general chain, if any. Okay, so for this one, how would you describe the association between the median age of marriage from women and median age of marriage for men in the 50 state and the District of the Columbia? So you're gonna say, oh, this is a positive, right? Because it's going up. Positive chain, right? Is also for the second one, how the shape is a linear, right? Usually it's look like a line. The model one is like a line. And the last one is a strength or weak association between two these. I'm gonna say it is strong because you can see is have the point is close to each other on the line. So now let's move to the next one. Okay, so the association between median age of marriage for women and the median age of marriage for men is positive, right? So as I state in the last page, and linear, right? Okay. In the other word, women who marry at an older age tend to marry men who are an older age. That is correct. The association is strong because there is very little vertical variation in the graph. So you can see there's a little vertical variation in the graph, right? See see how it close each other for the point here, right? So the only one that have a little bit farther than each other, maybe this one, but it's mainly is close to each other. So now let's move. Now we're gonna be carefully describing association. Okay, firstly, always use phrase like tend to, right? We don't want to say exactly or something like that. It's just like tend to, right? When describing an association, because the chain you are describing has variability, the association you are describing may not be true for all individual, right? So always point out any data point that appear to be unusual. Okay, so there is if there is some unusual one, you should point out that data or not part of general pattern, right? Okay, so I have finished section 4.1, and I'm gonna stop this video, and I will move to section 4.2 later. I see you guys later. Bye.